Good afternoon. My name is Barry Schomover. I'm a Microsoft reference architect at NetApp. I've been at NetApp for about 18 months. Before that, I was with Microsoft for almost 10 years. I was on the Windows Server team and for the System Center team on Microsoft Operations Manager for about 8 years. I was on the Windows Phone team for about 2 years. So if you love the Windows Phone, you're welcome. If you don't, it wasn't my fault. I'll give you a really easy way to remember my name if you haven't seen me speak before. If you cross the L in my name and make it a T, you'll never forget it as long as you live. My initials are BS, so easy childhood. So what I wanted to do is spend some time today going through our solutions and how they plug into the Microsoft Cloud, both on-prem and things like Azure. So real quick, I'm going to talk about NetApp, just a few slides on that. I'm going to fly through them very quick. Marketing helps pay for the show. Thank you, Calvin. So I have to go through these slides. And I'll kind of go through a scenario. I'll set a scenario that you all have probably either been through or are going through. And I'll show you how we can help. And I'll talk about how we all put it together. So, very quick intro. How many people here don't know who NetApp is? One person. Okay, it's NetApp, not NetApps. Okay, we're a large storage vendor, one of the largest. We have over 12,000 employees, lots of revenue, lots and lots of patents, and we'll talk about some of those patents today. This is an eye chart, and I apologize for it. I'm just going to throw it up there real quick. But really what this slide shows, you brought me a drone. Awesome. No? What this slide shows is simply that we've been doing this for a while. We've been partnered with Microsoft for a long time. We've won a lot of awards. In 2013, we actually won Server Platform Partner of the Year, which is pretty amazing considering we don't build any servers. Okay. So looking at the cloud, you've seen pictures similar to this, and you've seen the Microsoft 3 cloud story. Right, where you've got your cloud service providers, you have your hyperscalers, and you have your private cloud. What we do when we enable you is really we're about the data. We want to help you maintain your data sovereignty. We want you to be able to control your data while still being able to pick and choose which cloud you're going to sit in and when you're going to sit in one cloud versus another. What I'm going to try to do today is I'm going to try to spend very little in slides. And I'd rather show you guys demos. Some of those demos will be live. Hopefully the live ones will work. Some of those will be recordings. Some will be a combination, just because of timing and whatnot. But let's kind of set up a scenario. Before I offend anybody, how many people in here are CIOs? Perfect. Okay. So your CIO comes to a conference. They hear about this Microsoft conference. Microsoft is giving away T-shirts and great food. So they come to this Microsoft CloudOS vision, and it might just be Microsoft Ignite. So your CIO is here, and your CIO gets to see this slide. Come on. This slide. All right? How many times have you seen this slide this week? Come on, you've seen it more than that. People. And then they start learning about Windows Server and Hyper-V and System Center and Azure Pack and Azure Stack and the kitchen sink and PowerShell and all these different technologies, right? And what happens after that? You're going to get Lumberg, right? Come on. There we go. So I got my Lumberg outfit on. Okay? So now your CIO wants you to do a bunch of things for them. Wait, I have the glasses too. And I have my mug. Okay? So, now he goes, yeah, I'm going to need you to bulletproof our SQL environment. And I need you to do this while leveraging Azure. I also need you to make sure that we have full control of that data. Easy, right? Don't forget, we need to back it up. It needs to be secure. Also, he found out the enterprise agreement we have you have with Microsoft includes Hyper-V. Why are we paying all this money to VMware? I want you to get off VMware stat. And Microsoft is going to support for Windows Server 2003. We need new hardware. Get it quick. And all of this has to be managed by System Center. So these are the problems, the challenges that you guys have today. You may have some or all of these. So let's start looking at each of these, looking at the scenario. Looking at the first, I'm going to switch glasses. Looking at the first two buckets there, that's really data continuity, right? I need to be able to ensure that I've got my systems up all the time. I need to be able to scale them out if I need to. I need to be able to do disaster recovery, and I need to back them up. So how do we help? If we look at those three sections, some of the integrations that we have. Under Azure, these are some of the technologies we'll talk about. NetApp Private Storage for Azure, Azure Site Recovery with SAN replication, and something new that we've added, which is Azure Site Recovery with NetApp Private Storage. SteelStore, our backup solution. System Center with Data on Tap. We have a PowerShell toolkit we'll talk about. SMIS Provider, our plugin for System Center. On-Command Shift, a new product that we announced on Monday. SnapDrive Snap Manager for Hyper-V, and for some of the applications, SQL, SharePoint, and Exchange. So lots and lots of different solutions around Microsoft. Let's look at that first one. How do we bulletproof our SQL workloads? So, the ask, we want to enable scale out of our SQL environment. We want to leverage Azure's connection speed. We want performance, scalability, and cost. We want to maintain our data sovereignty. And this is key for us. We want to leverage Azure and NPS for NetApp Private Storage for Azure, NPS for Azure. So, this is your data center. For the rest of the session, we're all part of Seattle Retail. Now, Seattle Retail is a standard data center. We have our NetApp storage, we have network, we have compute, we have the operating system, and we have our databases on top of that. Azure has a similar model. The problem with that, the challenge that we have, is due to regulatory reasons, due to privacy reasons, due to company policies, we cannot or do not want to put our private proprietary data in Azure. So what do we do here? We've partnered with Equinix. Anybody here heard of Equinix? A few. So really what they are is they're either located within the Azure data center or adjacent to the Azure data center. You get your NetApp controller and you put it in a rack in their space. It's behind a cage. This is important. This is your controller. It is not owned by them. It is not owned by Azure. It is owned by you. Which means that if they get subpoenaed, that is not their data. That is yours. They don't have passwords to it. They cannot get into it. It's behind a cage. And using SnapMirror, we can replicate between the on-prem environment and the cloud environment. Through ExpressRoute, we can get sub-1 millisecond connection speed between your NetApp controller in Equinix and Azure. So that means now I can put my compute in Azure, I can put my database on my storage, and I can do failovers. Okay? So I can burst to the cloud, I can maintain my data sovereignty, and it's also a multi-cloud solution. One thing that I'll demo today is I'll show on-prem versus Azure, but we've demoed on-prem, Azure, and AWS. So imagine a SQL cluster that has a node in each one of those clouds, and using always-on availability groups, I can fail over in real time to any one of those clouds. So let's do a real quick demo of that. I'll try to do the live one here. Let's see. Okay. I don't want the video. Let's bring this across. Okay. So I have a SQL cluster. I have 2 nodes. SQL 01, that sits in Azure. SQL 02, this was an on-prem. If I look at the role, it's currently sitting on 2. So I have a SQL database. It's sitting on node number 2 on-prem. What I'll do is I will fail over, simulate a failover by stopping the cluster server on 2. What you'll see will happen here in a second, it's going to go into critical, stopped. You see it switched to 1, and now it's powering up in the Azure instance. So if I connect to Azure, what will happen here, I can see my network addresses change down here, SQL is coming online, and I'll actually be able to fail over. Okay? So again, multi-cloud, single cluster, I can fail over back and forth. And NPS allows me to do that. I own that data. I can synchronize it at all times. I can fail over back if I choose to. So real quick demo there. Now, one thing that's important to understand with NPS, this is something that's real. This isn't something we just showed and it's conceptual. We have partners that are building on top of this. We have customers with this. In fact, we have Sean Peterson in the audience, right over there. He's with Accenture, and they work on something called Hybrid Cloud Solution for Microsoft Azure. They're working with customers on this solution. It's being implemented, customers are using it, and we're getting a lot of feedback on it. NetApp Azure Site Recovery. How many people have heard of Azure Site Recovery this week? A few people. Okay. So for those of you that haven't, let's look at what Azure Site Recovery up until this week was 2 different scenarios. The first scenario was that you had 2 data centers, and you could, using Azure Site Recovery, you could fail over from one physical site to the other physical site. And the way that it was done is with Hyper-V replicas. So Azure Site Recovery would handle everything. As you can imagine, it can take a while to fail over the Hyper-V replicas. What we announced and what we first showed in Tech at EMEA in November, I believe it was Azure Site Recovery with SAN replication. In that scenario, the controller had SnapMirror between it, so I had identical copies on both sides. And when I performed the failover, we didn't use Hyper-V replicas. We failed over almost immediately using NPS. Sorry, using SAN replication. So now I had 2 data centers, and I can replicate from one to the other, and I can do disaster recovery from one side to the other. So that's great. But what if I have a scenario, System Center would sit there, and Azure Site Recovery would be the orchestration engine between them. But what if I want to do the exact same thing, but your data center either doesn't exist, I don't have a second data center, or you want to shut down a data center. It's time to update a data center. I had a customer yesterday come in and say, we have an aging data center. We don't want to replace it. Because most of the time it just sits there idle. I have a lot of resources invested in it. So I want to get the same kind of functionality without the resources. So the way we do that, Azure, obviously, Azure Site Recovery, and something that we announced on Monday, which is Azure Site Recovery with NPS. So remember I talked about NPS. Right? Looking at the scenario again, that's what we looked at before, right? So on the left, I have my physical data center. On the right is Azure with my NPS controller and Equinix. What we do now, System Center gets put on-prem. I should have it anyways. Azure Site Recovery, again, becomes the orchestration engine. And I get an on-demand data center. Some key things that are important to remember here. What will happen is, when I fail over, the compute will fail over with Hyper-V replica. The reason that's the case is because we cannot create a C drive in Azure. Azure does not allow that. So we will replicate the C drive using Hyper-V replicas, but the compute, the data, the SQL databases will get replicated and will fail over through NPS. Does that make sense? Okay. So C drives will still be Azure Compute, the D drives, etc., or, as I'll show in the demo, the actual disks that get mounted on it will be on the NetApp controller. So you only pay for compute when needed, and you pay a small amount of storage to store the shutdown VMs while they're in an off state. We're looking at other scenarios, like being able to take my environment and replicating it to the cloud as a clone of my environment so I can do testing, like patching. We also learned from Microsoft that if you do that scenario, you don't need a second set of licenses. If you're doing dev tests, if you're doing a testing on patching, the licenses you have on-prem will cover the clone that's running in the cloud. And they give it to you for 31 days free. So let's look at that real quick. Okay, so a little bit of setup here. On the left, I have a Hyper-V environment. And you can see I've got two VMs. I know it's hard to read, ASR Test VM1 and ASR Test VM2. Those are two nodes in a SQL cluster. Two nodes in a SQL cluster that are running SQL. And they're sitting right, here's one of them, and the other one's right here. I'll come up here in a second. So I have two VMs running in a cluster. VMM1, this is my SCVMM, sorry, not that one, this one. This is my SCVMM environment. I can connect to it and I can see the VMs that are running on it. I have a second VMM server, that one's running in Azure. So I have one VMM server running in the cloud on-prem, one running in Azure. If I connect into the Azure portal, over on the left, you'll see recovery services. Under recovery services, I have my different services. This is the one that we're using here, and I can look at what's protected. I can see a couple of VMM clouds that are protected. And you notice two things. You notice that I've got a primary compute sitting on VMM1. There's two virtual machines on it. The target failover is Azure. I also have my two storage environments. I have the on-prem storage, and I have the NPS storage in Equinox connected to Azure. If I look at resources, networks, if I look at my on-prem network and I look at what happens when I connect it to Azure, I will get this funky name right here, NPS Azure Net with a GUID. This is my express route connection. This is my dark high-speed VPN that connects my NPS controller to Azure. And if I look at my storage, and I expand that, I'll go from on-prem to the cloud. I should see the different LUNs that are mapped. So I have two different ones. I have the quorum and I have the data. One on the left is on-prem. The one on the right is in Azure. Okay, quorum and my SQL data. And those are mounted as disks. So let's simulate a failover. If I go to my recovery plans, you can see I've got compute and I've got storage. The trick is we have to do compute first, and as soon as we kick off compute, we can kick off storage. So let's do that. I'll just do a failover, planned. I'm going from VMM01, remember that's the on-prem one, to Microsoft Azure. I'll start that. And then I can fail over the storage. So storage, I'll do the same thing. I'll go from VMM1 to VMM2. There's currently a bug in the UI that doesn't give me the right direction, so I'll change direction. Now it's going to go from, sorry, wrong one. I'm going to go from VM1 to VM2. The bug is on the failback. And I've kicked it off. So now these jobs are starting. It takes about 15 minutes to do the failover. Through the magic of video, we'll kick off where we left off. Okay? So now what it's doing is I'm looking at the actual job. These are the two jobs I just kicked off. One is failing over the compute. You can see that it's failed over the two VMs. Second here, I'll look at the storage, and you'll see that in storage, it's failed over the storage as well. So what I've effectively done is I've taken my two on-prem VMs, and I've moved them up into Azure. Now I can see two running VMs, and those VMs will now be running in Azure for me. Okay? So effectively, now if I fire those up, I should be able to see them. Should be able to connect to the cluster. My environment's back up, but now it's running in Azure instead of running on-prem. Two VMs are off. There's a couple things that we have to do in our environment that you won't have to do in yours. In your environment, you're going to have Azure Active Directory and DNS, and IP addresses will just work. In our environment, the IP addresses in Azure are different. So what we're doing is we're doing a couple things. First thing we do is we change the DNS. I know it's really hard to read. The second command creates a load balancer. That maps our network, so we can route the network. And then the next two commands just create two endpoints for us for the two servers with specific IP addresses. That allows the cluster then to reconnect to bring those two nodes up with the new IP addresses. In your environment, the IP addresses won't change. Because in your environment, it'll be pretty much the same network as far as it's concerned. There won't be no changes. And I can go ahead and just connect to the cluster. Now, fail back works the same way. I'm not going to show you that, though. What fail back does, let me pause that there. What fail back does is just the reverse. That takes longer because now I have to synchronize everything back. Okay? I've been synchronizing all this in real time. When I do the fail back, that takes a while. Now, you'll notice in Disk Manager that I have two disks mounted to it. I've got this volume, this 900 meg volume, and I've got this 100 gig volume. The 900 meg volume, that's my quorum that I saw before on my storage. The 100 gig is my SQL data. What's important to note is they're just mapped as iSCSI into these particular VMs. So the VMs just see them as another disk. They have no idea that it's sitting on a controller in a totally different part of the data center in a rack on its own. Completely transparent to the OS. Now, if you want to see the full semi-live demo, we can show it to you live as well, but we have it recorded from start to finish. From fail over to fail back, you can see the whole process. The video takes about, I think it's 8 minutes, start to finish. Through the magic of video, we've accelerated some of the times where it's doing the processing. Okay? So there's two parts of my data continuity. I can scale when I need it. Disaster recovery allows me to fail over from one environment to the other. But what about backup? Well, with backup, we want to be able to look at Azure again. Azure has all this storage. What is it? It's like a penny a gigabyte a month for blob storage. I've lost more change on the way here than it would have cost me to store some of my stuff on Azure. Right? Very inexpensive. But again, I want to maintain my data sovereignty. I want to make sure that whatever I put up in Azure, even if somebody gets a hold of it, they can't do anything with it. So if I'm going to put something in blob storage, it better be secure. And also, I may have a lot of data. So even at that 1 penny per gig, it's going to potentially add up for me. So if I can minimize that cost, that's great. How do we do that? Azure and NetApp Steel Store. So here's a scenario. Same scenario I had before. I have my Seattle Retail on the left, Azure on the right. We bring in the NetApp Steel Store appliance. This is an appliance with a bunch of disks in it. And really what it does is allows you to create a CIFS share that Windows understands. And you point your backup story your backup solution, I should say, you point your backup solution at that share. We will then collect that, we will dedupe the data for you, and archive it locally. So that's the first step. We store all your backup, we dedupe it, so if you're backing up a bunch of web servers that have very similar content, they're all being backed up. The stuff that's the same, we just dedupe for you. So you save a lot of storage that way. So now I have an archiving solution on-prem. But how do I leverage Azure? What happens if that appliance gets stolen? Or I have a flood in the data center and I lose that appliance? Well, we have the ability to connect it to Azure Blob Storage. What do we do there? We back it up to the cloud, we encrypt, dedupe, and compress the data, and we have it on both environments for us now. So now we have a solution that can archive on-prem, so we can have that very fast backup recovery, but we can lose that entire backup and know that we still have a backup in Azure Secure. I can come to a different data center I can restore from it. Let me show you a quick video of what that looks like. So I'm going to log into the environment. This is just the web interface for it. The first thing I'm going to do is I'm going to connect it into Azure. We can connect it to a bunch of different environments, but I'm going to connect it to Azure Storage, host name, the blob store. I'm going to give it an encryption key. Right, this is my key. This is how I make sure that nobody else can see the data. And I'm going to apply that. That sets the environment to actually talk to the cloud. Next thing I'm going to do is I'm going to create a CIFS share. So I'm going to connect into storage, CIFS. I'm going to create a new CIFS share. In this case, I'll call it CIFS. I'll give permissions to everyone. Obviously, in a real environment, I won't do that. But I'm going to give access to everyone for that particular share. The next thing I'll do is I'll connect into my backup software, NetBackup in this case. And I'm going to just point the backups at this new CIFS share that I created. There's my Steel Store. And I'm going to send it to that particular path that I just created. And then I perform a backup. We'll back it up to that device, the Steel Store appliance. We'll compress it. We'll dedupe it. But then I can also look at reports. And these are some interesting reports that I'm going to show you. Okay. Looking at reports, I can look at how much data they actually sent to the cloud. So in this case, what you'll see is you'll see the blue line that spikes up. That's how much data I backed up. The red is how much I actually sent to Azure. So even though I backed up a ton of data, I have almost a 14-to-1 compression rate on that data because of compression and dedupe. I can see the throughput, how much data was written to and from, how much data and how fast I sent it to Azure. The replication, how much data was replicated into Azure. And finally, my cloud operations. Okay. I can see how many operations per second is happening in the cloud. So very, very cool solution. We can tell you some more in the booth, but it gives you that archiving capability both on-prem and in the cloud. Okay, this is a fun one. So now we want to take our VMs and migrate them from one hypervisor to another. In this case, from ESX to Hyper-V. We want to minimize downtime. And we want to make sure that we hit our maintenance windows. How many people have done VM migrations before? How fast are they? They're not very fast, right? There's two types of solutions out there. There's what we call cold conversion solutions, or migration solutions, and warm migration solutions. The cold migration solutions will bring the VM offline, will block copy the entire file to another system, and then we'll convert that file. There's great things about it. Those particular solutions, they tend to be free. That's the only good thing about them. They don't really fit in the maintenance windows. They're very difficult to use. My server is online for literally hours or days while I'm doing the migration. Warm ones are much faster. What they do is they create a second server. There's an agent on both. They replicate the data. Once the data is replicated, they shut the VM down, reset what boot partition it boots off of, and bring it back up. So I have about a 5 to 10 minute downtime. So that's great. They're very fast. But They tend to be very expensive. And they also take a lot to get them up and running, synchronizing, and it can take weeks to synchronize the VMs, depending on the size of the VM and how busy the VMs are. So what do? We have a solution that we announced on Monday called On-Command Shift. I'll talk a little bit about what it does. But let's look at the scenario. Here's my storage. This is my lab in Bellevue, Washington. That's a city, not a mental institution, although some days it feels like it. If you met some of the people that I work with, you would know. So that's storage. We have network. On the left, I have my ESX environment. On the right, I have my Hyper-V environment. And I'm going to install an on-command shift server. This is not an appliance. This is a piece of software that gets installed either on a physical box, on a virtual box, a Windows box. And it then orchestrates, and that's the key word, it orchestrates the migration of a VM from ESX to Hyper-V. The reason I say that it orchestrates is it doesn't copy any files. There's no block copy at all in this particular solution. So what is it? It's a solution that's built on a tool that we released about a year ago called Mat for Shift. I'm one of the people that wrote that tool. It's PowerShell. It was a community-supported tool. We know from data that we collect that customers opt into. Over the last almost 12 months, customers have migrated, again, that we know of, that we've collected, almost 1,400 VMs, 2,600 VMDKs, over 100 terabytes of data successfully with this tool. So we have a lot of history with this tool. And the technology that's built on has been around even longer. It's bidirectional. That's something new, so we can go from ESX to Hyper-V, Hyper-V to ESX. It fully migrates it. It's near zero touch. What I mean by that, when I show you, assuming the demo will work as I expect it to, you'll actually see that I don't do anything in the 6 minutes that it runs. I just sit there and watch it. It's controlled via PowerShell. It's a PowerShell module, so it's very scriptable. I can put it into a bunch of automation engines. And it literally takes minutes from start to finish. And I'll explain how it does it and talk about the kind of speeds we're talking about. So here's what it does. One thing that we can do that no other vendor can do when it comes to VM migrations is we understand the files as they sit on the disk. When you put a VMDK file on our file system, on our Waffle file system, we know where every single block sits. So if I say clone this file, I don't need to copy it. I just have to make Windows think that I copied it. And it's kind of hard to imagine. And when you see it happening, either live or in the video, depending on which one goes for me, it looks like magic. It's nearly instantaneous. And think of it this way. When you go to Explorer and you pick a file and you go Control-C, Control-V, and it's a large file, what happens? You get a dialog box and you get a copying, right? If you go Control-X, Control-V, what happens? Instantly comes up. Why does it do that? Windows is not copying the file. It's just remapping where it sits in the directory structure. That's kind of what we do. Okay, so we clone it. So in this example, I have a VMDK that's talking to 5 different blocks, A through E. So that's one piece of magic. The second piece of magic allows me to take a single volume and expose it with multiple protocols. That means I can create a volume, I can expose it through NFS to ESX, through CIFS to Hyper-V. Now I can have both hypervisors see the exact same data, same files, same folders. The last piece of magic is part of our PowerShell toolkit. What it does is it allows me to not only clone the file, but convert it at the same time. We reverse engineered the VMDK file format. We looked at the VHD and VHDX specs, and we figured out the differences. In near real time, we're talking seconds, we can take a VMDK of any size, convert it and clone it to a VHDX or VHD. So when we do that, our file system is smart enough to go, oh, A through D is shared across both files, but F is different. So when we write the file, we just write the differences between the files. And our file system takes care of everything. So when you look at the disk, you'll have 2 copies of those files in 2 different folders. 99.9% of those files are identical. If you look at a 50 gig VM, the differences between a VMDK and a VHDX is about a meg. So that means when I clone that file, I get 1 extra meg of storage. That's it. Which is great, because as I'm cloning it and I'm migrating, I don't want to double or triple my storage. And as you'll see what we do, we actually have 3 copies of it, and I'll explain why. We then go and create the VM for you, handle all the differences. Here's how it works in a little bit more detail. On the left, I have my ESX environment, on the right, Hyper-V, obviously. I'm going to do an ESX snapshot. What the ESX snapshot does is coalesce the VM for me. It gives me a nice single VMDK to work off of. I'll then snapshot the entire volume instantly. I then clone the VMDK. I make a full backup of all the VMDKs that exist in for that particular VM. Why do I do that? That is my get out of jail free card. That enables me to fail back to an original backup of the VM should anything happen. We then collect all the network and disk information. We inject PowerShell into it to rehydrate on the other side, and I'll show you that, talk about that. Uninstall the VMware tools. This takes the longest of anything we do. What I'll show in the demo is a 1.85 terabyte VM migrated in 6.5 minutes. If all works well, they'll do it while we're sitting in here. Okay? The actual conversion takes just over 3 minutes, 3 hours, 3 minutes, 20 seconds. Of those 3 minutes, 20 seconds, about 2 minutes is uninstalling the VMware tools. So that takes the longest. We shut down the VM, we clone and convert the VHD, create the VM, mount it, start the VM, rehide the network, so we run a bunch of PowerShell that rehydrates the whole environment. We reboot the VM and we're done. So let's see if I can get a demo going here. Cross my fingers. If not, I'll show you a video. Okay, so setting the environment. On the left, actually, let me go in here first. So you see the tech-ready VM? On the left, it's highlighted. On the right, you'll see I've got 1.81 terabytes used. It's made up of 4 disks. Here's the VM here. So that's the VM. Okay, so the VM is running for me. Move it over to the side here for a second. My Hyper-V environment has nothing running in it. I have 2 shares. This share on the left is my ESX environment. This is my ESX data store. I can see under Tech Ready. Let me zoom in a bit so you can see it better. You can see I have a 500, a 600, a 700 gig data drive, and I have a 50 gig OS drive. Those are the VMDKs. In a second here, I'll clone those. On the right, this is my Hyper-V share. Nothing in there yet. Okay? And it's all through PowerShell. So let's see if the demo gods are shining on me. So the only thing I don't have control of is when I submit the job, this is a beta version of on-command shift. It either picks up the job immediately or it waits 3 minutes. If it picks up immediately, we'll see it right away. So I just go convert the virtual machine. If I could spell virtual machine. I'm going to give it a name. Tech Ready. The source is going to be ESX. The destination is going to be Hyper-V. That's it. That's the command I'm going to issue. Now I can put multiple in the queue. Today in on-command shift, we do it serially. We'll do one at a time. So every 3.5 minutes, we'll convert a new VM. So we actually can have multiple VMs being converted at the same time. Because the last thing I do after I convert the VM is I power it up and it does its own thing. I can start the next one at that point. Yes, I want to convert it. And it generates this job for me. And let's see if this worked. So I can show the loop. There's a little script I wrote just to watch it. There, so it started. Perfect. Okay, so here's what's happening. It's looking at what's happening. It's looking at the old snapshots and deleting. Watch this folder here carefully. It's going to validate that my vServer is all set up, and now it's going to clone the disks. Watch. Do you see it? It's cloned those disks. That's how quick it is. So do I actually have 3.6 terabytes of storage used up? No, I still have 1.8 terabytes of storage used. What it's doing now is it's pre-staging the environment for me. It's connecting in, it's collecting all the network information, all the disk information. It's generating XML configuration files that's injecting into the guest. It pushes a bunch of PowerShell scripts into the guest for me. It's modifying the registry temporarily to auto-log on when I boot it up in the Hyper-V environment and run these new PowerShell scripts that are going to go back in and reconnect the network, rehydrate the network. So what does that mean? I don't have to do anything. I just have to verify it. If I have 4 network adapters and they have custom names and static IP addresses, it does it for me. Okay? Now, this stage takes about 2 minutes. Remember, it's uninstalling the VMware tool. So let me explain, to put in perspective, how fast this is compared to some cold migration technologies. Let's look at Microsoft MVMC. Anyone used MVMC before? Okay. MVMC is a cold migration technology. They'll take the VM and they'll copy it over and they'll convert it. So in the time that it's going to take us here to migrate this VM, I can leave this room, I can go find the Starbucks, stand in line, order a cup of coffee, get my coffee, and come back. 6 minutes. 6.5 minutes. Have you seen that Starbucks one? Okay, 8 minutes. 8 minutes. Or I can go get a free coffee. How's that? Okay. Now, with MVMC, 1.8 terabytes, it takes about 1 gig a minute. That's 1,800 minutes. That's 30 hours. That's 1 day, 6 hours. In the time that it would take me to migrate with MVMC, I could leave this room, I could go stand in the cab line, the entire cab line, catch a cab to the airport, fly to Seattle, take a cab to Pike Place Market, go to the original Starbucks, get a coffee, tour Pike Place Market, see the flying fish, go up the hill to the movie theater, watch the Avengers, come out, meet friends for dinner and drinks, take a cab back to the airport, fly back to Chicago, catch a cab to the convention center, and that'll give me another 6.5 hours to kill before the migration is completed. That's assuming it doesn't fail. Okay? So, now that I've blabbed for a little bit, you can see that it's starting to create this. It's created a new VM for me called TechReady. My memory starts at 1 gig, goes to 4 gig. If I look at the other one, that's what it was set at. My networking is now set up. And if I look in here, and here are my disks. They've already been cloned and converted. Every 3 seconds, it takes and it converts this disk. It's now running the VM. On the left, you'll notice as this VM is booting up, Restored Source Virtual Machine is now complete. You can see I only have 1 copy of these disks now. What we did as a last step is we reversed the process. We took that original backup we created right at the beginning, and we'll reassign that as the primary disk. So now, if something goes wrong and I want to fall back to ESX, I literally turn off the VM in Hyper-V, I power it up in ESX, and I'm back to where I was before I started the migration process. Okay? What you'll see, and actually while it's still doing that, I'll go and, what is it? I think it's get shift report. And if I'll zoom in, it took 211 seconds to actually convert the VM. The rest of the time, it's setting it up. So you can see now, all that hex, that's the PowerShell rehydrating the network. This will take about 3 minutes, 2 to 3 minutes, and I'm done. That's it. 1.8 terabyte VM migrated in 6 minutes. That's pretty impressive. Okay? So it's real. And over the next few weeks, we'll release it. We just announced it on Monday. It'll be available in the next few weeks. One thing I forgot to mention is the price. If you have an NetApp controller and you have CIFS, NFS, and FlexClone, I'm afraid to say that it's free. Okay? I know people are upset and they're going to leave. And if you come upstairs, we'll give you a free T-shirt too. So, okay, so that's on-command shift. Right? Very cool tool. We've had it. It's built on technology we've had for a while. We have customers that are looking at migrating thousands of VMs with this particular tool. As you can imagine, Microsoft kind of likes us. I'm sorry, does it work for Unix? Great question. The question is, does it work for Unix? So today, it's only Windows. Unix is on our roadmap. With our Map for Shift tool, we do have a partner that has a Linux solution. So there's something we can do in the short term. Longer term, it will be in the product. We're also looking at other hypervisors and potentially hyperscalers to be able to shift our data between multiple hypervisors. Right? Today, it's ESX and Hyper-V. We have several of different solutions on our roadmap that we're looking at. Okay? Let us release this one, and then we'll kind of start talking about what we're doing next. Okay. I don't need to show you the video because it worked. So, next. How many people here still have 2003 servers? A few. Okay. So, how do I get rid of those? Right? Microsoft is end-lifing this for me, which isn't really helpful. But, so I want to be able to build a new environment, potentially. I need to bring these to the new era, so I'm going to have to install new systems, potentially, or upgrade. But I want to make sure that I put on a new infrastructure. So I want to minimize the time to deployment. I want to ensure that the hardware and software is all compatible. I don't want to spend a bunch of time testing a bunch of hardware and finding out that they don't work well with the network adapters that I bought, and it doesn't work with the network switch, and the storage isn't quite what I expected. I want a solution that's been tested and vetted, and I know that it works, and that I can expand. So I want to minimize the cost, both of the hardware, the software, and the maintenance of it. That's where FlexPod comes in. So, FlexPod is our fast track. I'm sure you've heard a lot about fast track the last little while. You've probably seen Microsoft talk about some of their solutions. This is our version of it. We've had it for a while. We're on version 4 right now. It's a converged infrastructure from NetApp and Cisco for Microsoft Private Cloud, in a nutshell. Right? So it has NetApp storage, Cisco UCS blades, and Nexus switches. And if you want to see one, we have one on the show floor. It's running all of our demo environments on the show floor. So if you actually want to see one in real life and touch it, it's not behind glass. Don't pull any cables, please. But it's there. And also we have, if you have an iPhone, I don't know what you're doing with an iPhone or a Microsoft show, but if you have an iPhone, you can get this little virtual, you build this little paper box, and there's a little app you download, and you can actually see it in 3D. It's a little virtual thing through the camera. It's really cool. So reduce risk, it's pre-validated hardware, so we've tested the hardware. We know the drivers are in there. We have a document this thick that takes you step by step as to how to configure it, how to get it up and running, how to get private cloud on it, how to get System Center on it, the works. Right, so lower cost compute and storage. It's a turnkey solution. You virtualize the entire environment. It's also easy to scale. I want to add more, plug a couple of cables. So I couldn't bring one here, but I took a picture of it. There's the FlexPod that's sitting in our booth. Lots of blinking lights. Now, here's what I want you to really notice. I want you to look at this picture here. If you come down to the booth and take a look, and look at some of the competing ones that are on the show floor, you'll notice that ours has almost no cables in it. If you look at some of the competing solutions, and I won't mention names, there's over a mile of cable in the cabinet. A mile of cable. The number I heard was $75,000 worth of cables in a single cabinet. Okay? So if you look at each of the blades, it's a 2U blade, not ours, the competing one, 2U blade, 4 enclosures in the chassis. Each one has 4 fiber channel, 1 management port, and 1 power. That's 6 per, that's 24 cables per. We have, down here is the UCS chassis. It holds 8 blades. Every blade has 1 cable coming out of it. There's 4 power coming out of the chassis. Okay? So that's 12 for that chassis, for 8 blades. Really, really cool. Come down, take a look at it. We'll walk you through it. We have some guys in black shirts that are very proud of being there, and they'll show you talk to you all about it. Okay. Now, System Center. How many people here use System Center? How many people here plan on using System Center? A few. Okay. How many people are excited that System Center 2016 is coming? I know I am. Have you noticed that now, what is it? It's Microsoft Operations Management Suite. Mom is back. I worked on the Mom team for years, and now Mom is back. Okay, so we don't want to learn new management tools, right? If you don't have management tools, we have tons of management tools from NetApp. We can give you any tool that you want to manage our infrastructure. The nice thing about the System Center ones is they plug into what you know, and they pull in all the other components. So if you look at, say, FlexPod, part of the power of FlexPod is not only that I'm using the hardware, that I can plug in new hardware and I don't have to cable a lot and it's really easy to scale. I can use System Center to manage the whole stack. I have Nexus management packs. I have UCS management packs. I have NetApp management packs. So we want to leverage our tools with System Center to do this. So let's look at what it looks like. This is the Microsoft Private Cloud, and we've seen something similar to this. All starts with Microsoft Server, Windows Server, and Hyper-V. On top of that, I have my apps, Exchange, SharePoint, and SQL. I have System Center managing that, so I have SEVMM for my VMs, for my Fabric. I have Operations Manager for monitoring the whole environment. I have Orchestrator for orchestrating the environment. I have provisioning, monitoring, automation, and underneath that I have my compute, my network, and my storage. And Windows Azure Pack sits on top of all of that. Right? Azure Stack's a little different. We're just learning about that. But this is how it sits today. This is the world as we know it today. So now if we look at NetApp, how does NetApp fit into this whole thing? Excellent. This is the 3rd session that I've seen this happen in. Okay. So, how does NetApp fit into this whole thing? So we have plugins that plug into each one of those components. OCPM, on-command plugin from Microsoft. Complex name. Think of OCPM, that is our management pack. That is our orchestration pack. Okay. We have the PowerShell toolkit. And all of this comes from DataOnTap, which is our storage operating system. That's where we get provisioning, configuration, virtual network monitoring, backup disaster recovery. Through PowerShell, we can do automation. Windows Azure Pack just continues to work. So if you implement all of the System Center components, you put Windows Azure Pack on top of that, and you have our plugins, everything just works. There's nothing special, nothing extra you have to do. Finally, Snap Manager for Exchange, for SharePoint, for SQL allow you to manage those applications as well. So let's dig in a little bit further. I'll talk about each of these in a little bit of detail. So on-command plugin from Microsoft, OCPM. That is our management pack. So 3 components, management packs, orchestration packs, as well as some UI integration into SEVMM. DataOnTap SMIS agent. This is an industry standard agent that allows SEVMM to learn about my complete storage environment. And when I go and deploy a new VM, it just goes and it knows how to do it. My VMM guys don't need to know how to provision storage. We just say we want a LUN of this size. We want to create a share on the controller of this size. It just does it for you. You don't have to know any of the commands. If you want to use the commands, we have the PowerShell toolkit. PowerShell toolkit is currently about 1,400 commandlets. It's really our SDK with a PowerShell wrapper around it. So Shift uses some of the PowerShell commandlets in there to do the conversion. Pretty much if you can imagine doing it on a NetApp controller, we have a command for it, PowerShell commandlet for it. And if we don't have a PowerShell commandlet for it, we have this great little commandlet, new-nc SSH. You give it the SSH command and it just does it. So anything that doesn't have a PowerShell commandlet, we can use SSH for it. At our Insight conference, I spend an hour in a PowerShell presentation where I literally start with a controller that has an IP address associated with it and a network or username and password. And for the next 50 minutes, I fully configure that controller, all from PowerShell, meaning it's repeatable and it's scriptable, right? So using automation, I can say, here's a new NetApp controller. Plug it in, give it an IP address, tell Orchestrator to configure it, and Orchestrator will go and configure it for me. Okay, so let's take a look at some of these. I'll drill into this in a bit more detail. So let's start with Orchestrator. So this is my Orchestrator environment. It's a couple of things. We have some activities. These are the 7-mode. We don't really support our 7-mode stuff. Cluster mode is what we really care about. But to give you an idea of what the kind of things we can do, so this can leverage PowerShell underneath. Because PowerShell is built into Orchestrator, you can execute all these activities. So I can get the controller, I'm going to get the aggregate, I'm going to connect to the cluster, I'm going to create a volume, and I can provision the storage. Microsoft Office uses us, and what they do with Orchestrator is pretty incredible. What they used to do is they used to, when a developer wanted a new build environment, they would go to a portal and say, I want a new build environment. That would run a bunch of Orchestrator workflows that would then go through and build a whole environment in Hyper-V for them. Deploy VMs, deploy services, etc. What they do now with NetApp controllers and with our on-command plugin and our PowerShell toolkit, what they do is when a developer now says, we want an environment, they clone an environment that gets built at night from the nightly build, and the developer has it in 90 seconds. We went from like 6 hours to 90 seconds. When the developer is done, they go destroy, it blows it away. New build the next day, they get a brand new environment. That uses that FlexClone technology that I showed you, the SnapMirror technology that we have, and it uses PowerShell to orchestrate this. So very complex orchestration scripts. Now, the cool thing about PowerShell, if you work with PowerShell, how many people here have used Windows Azure Pack? So Windows Azure Pack, the orchestration engine, is the same engine that they use in System Center Orchestrator, but the GUI is gone. It's now all PowerShell workflows. So because it's already PowerShell and you're already doing everything in PowerShell, it translates very easily. You can perform all these complex tasks. So that's Orchestrator. Real quick view on what Orchestrator does. SEVMM, if I look at my fabric here, let me see. Actually, you know what? I'll show you a video for that one. I'll show you the VM provisioning. Okay. So I'm just going to provision a new environment here. This is the one I want to show you. Hold on. This one. Not the Vikings. There we go. Okay. So remember the technology that we talked about in Shift, the cloning technologies? I can leverage those same technologies in VMM. What I'm doing here is this is going to use the SMIS for me to create a brand new file share. So as a VM administrator, I don't need to know how to create a new volume or a new LUN in my controller. I just go do it, and it just does it. SMIS provider knows how to do it, has the credentials to do it. I don't even know what the credentials are to the controller or where the controller sits. It just does it for me. So I create that share. I then go and I add that file share to my Hyper-V box. And now, remember, what Shift allows us to do is when I have a file on one volume and I clone that file to the same volume, I can use that flex clone technology, right? Very, very quick conversions. Now what I can do, because of that share sits on the same location, I can take this template, which sits on the same volume, I can go and I can deploy it as a brand new VM. So I'll give it a new VM name. I'll just skip through the wizard. I can see the explanation if it's there, and I can go and deploy that. Now watch, this is in real time. What actually happens is we use what's called ODX, Offline Data Exchange, which kicks in that flex clone technology. So you can see the fast copy. It took, second here, it took 16 seconds, 17 seconds to copy an 8 gig VM. So now I can take a 50 gig VM and I can do it in a minute and a half. Deploy a brand new VM using that same technology. So by leveraging that NetApp storage underneath, I get that fast speed that I do with on-command shift. I get it in my VM provisioning as well. And the same is true if I happen to be using ESX. The last one I'll show you is System Center Operations Manager. I used to be on the Operations Manager team, and when I worked with partners a lot, and my goal with partners was always to have them build really rich, high, like multi-level hierarchical views of the environment, and NetApp did it. I'd like to take credit for it, but I can't. They had it when I showed up. I'd like to think I made it better. But very deep integration in Operations Manager. So if I look at this particular view, and this is a lab sitting in Bellevue, I can see I have 4 different clusters in my environment. I can look at things like my aggregates to show me all my aggregate volumes within, my aggregates within there. I can look at, actually I look at a disk. So I can look at disks. I can see all my disks. They can't all be healthy. Apparently they're all healthy. I can look at my logical interfaces. These are my virtual network adapters that sit within my environment. I can look at my LUNs. I can look at different nodes, the ports, the queue trees, etc. So I can look at all the different parts that make up my NetApp controller. But it gets even more exciting. I can look at the hierarchy of my environment. So here's my hierarchy. All right, so I can see each of my clusters. So I expand one of my clusters. If I expand Serenity, for example. Serenity is actually where the Shift demo ran. So under that, I can see a couple of things. I can see my network interfaces. I can see my nodes. Under the nodes, here's the physical disks that make up that node. So I can see every physical disk. If a disk fails, it'll become red in Ops Manager and tells me that it's critical. I can look at the enclosure. I can look at the fans. I can look at the power supplies. So I get notified if any of those components go offline. Under storage virtual machines, let me see which one of these is the Shift one. Here's Shift. So I expand that. I'll actually see what makes up that particular environment. So I can see I've got a LIF, got a couple of volumes, and from here I can actually look at the error as well. I can see the shares. I can open the Health Explorer, for example. Okay. So if I look at that particular monitor, this one, it happens to be the volume, the available space. If I look at it, I can see that currently I have no space on that particular volume. I've maxed out that volume. All right, so I get those notifications. Now, am I going to use Operations Manager to fix this? Probably not. But in most organizations, the storage administrators are going to be a different group. So now you can open up a ticket. You can say, here's the problem. This particular volume on this controller has run out of disk space. Go fix it. Right? So that gives you kind of a high-level look at that part of Ops Manager. We also have a bunch of reports associated with it. So with my reports, if I look at clustered, I can look at things like latency. And these just use the SQL reporting that's built into Operations Manager. I have dashboards I can look at it, and I can go and execute this particular. So let's see if I just go top 5 and run it. Let's see how long this takes, right? So we collect data both in real time, so I can show you those counters. Real-time counters that show you what my CPU is doing on my controller at this second. And I can also look at the data warehouse. What's it doing over time, historically? So I can look at performance. Oops. On that particular one. So I can see my top 5 storage virtual machines. I can see Shift is the one that's actually using the most. It's got the most latency. That's the one I'm hitting. The other ones are just idle, so they're not really doing much. So I can see these rich reports. If I switch back into monitoring, let me see if I can find some of the real-time ones. So like CPU utilization. So average CPU utilization, let's see if I have any data. There. So on one controller, I have some data that comes across. All right, so I can see that real-time data. I can also, with the reports, I can have it notify me and email me when storage hits a certain capacity or if it's growing at a certain rate. So very, very rich integration into the System Center suite, Operations Manager, as I showed you, Orchestrator, as well as SCVMM. So I don't need to show the video. So in summary, looking at the scenarios, bursting SQL to the cloud, that's where NPS for Azure comes in. Failover to SQL, it's NPS and ASR. Backup is where SteelStore comes in. For migration, I've got on-command shift. New hardware is where FlexPod comes in. And we can manage all with System Center. Bunch of information for you. Please do come into the booth. We'll walk you through a lot of these technologies. We've got deeper demos, deeper videos that we can show you. My Twitter handle is @ShiftMover, not the other one. You need the F. So I'll be tweeting a lot about these technologies, the System Center Private Cloud, on-command. Also, the red stapler, we're giving some of these away. We're also giving some money with them for the best tweets. So if you want to tweet, if you can do it with ShiftMover or hashtag NetApp MSIgnite. Tweet about the session, about some of the NetApp stuff, and you can win a bunch of different prizes. Also, we have I'll come back to the Q&A. We have if you text to NetApp to 40691, you can win. We've got over 600 prizes. We still haven't given away. There's a drone, a nice drone. We haven't given it away. Please don't win it because I want it. I would like to have one. They had this big long list of prizes. I went, the only thing I don't have on there is the drone. Let me win the drone. They said you can't win the drone. So I will definitely do that. Yeah, but I'll put it up there. Here we go. There it is. Okay. So hashtag NetApp MSIgnite, hashtag ShiftMover, and you can come down, and if you text it, you'll get a little URL, click on it, and you have to come to the booth, and we'll give you a shirt as well. Okay, so if you have any so that's it for me. If you have any questions, I can take them now, or I'll be here to answer them. Also come down to the booth, and we can answer them there as well. Thank you.